Welcome, everybody, to part 5 of this series on classifiers. So we're at the point now where we've created all of our classifier steps. We just started off by discussing how classifiers work and coded a little classifier. So it's a spam filter. And now we're at the point where we can actually build a pipeline that executes all of these classifier steps. So the first step in the pipeline is to create the data set, right? So create, move the cursor here, create spam data set. So that's the first thing we're going to do. So that first function calls this, and this is a data frame. It returns a data frame. So we're using pandas data frame. The create spam data set is all of the a mixture of spam and ham emails. So some of these emails are ham, which we consider good emails, and some of the emails are spam, which we consider undesirable emails. So we're going to load that into a data frame. We'll just put a little documentation here. So step 1 is load data. Okay, very simply. The second step is to pre-process and split the data. So this is kind of an intermediate step, I would say. Before we vectorize the data, we want to pre-process the data. A step like this would typically be pre-processing, cleaning, separating data up into different data sets. In this case here, we're going to separate, so pre-process, and split. So here what we're going to do is separate the data up into training data sets, testing data sets, and also the correct values of each one of these data sets. So you're basically telling the model, you're creating a data set where you're telling the model what is correct, so that when you go to the training step, that's part of the training process, is just to advise the model on what is correct and what is not correct. Or sorry, what is spam and what is ham? You're dividing it into those two categories. So classification, right? Dividing into two separate categories. 3 is to actually, I won't call this 3 yet. I'm just going to say vectorizer. We're going to construct a vectorizer first, and we're going to use this vectorizer in future steps. So term frequency, inverse document frequency vectorizer. So this is, we discussed this earlier. And the vectorizer, as you know, converts words into vectors, essentially, right? So vectors are something that can be ingested by machine learning models. It's also a very efficient way of doing things. Rather than working with text, we're working with vectors. Stop words equals English. So you're just specifying the language there. So third step is feature extraction. So this is vectorization. We've developed our training and test data sets, as well as the correct answers to these test data sets. And the next thing is to vectorize this data. So, and we're using term frequency, inverse document frequency for the training data, and same thing for the test data. Term frequency, inverse document frequency. So extract features. And just as a reminder to everybody, these functions that I'm calling, pre-process and split, create spam data sets, extract features. These are the functions that are already in this file right now, right? So, and I'm putting everything together in one file just to keep things simple. But in the future, or if you were to build something that was a little bit more robust and perhaps a little more complex with more detail to it, you would break things out into classes, and you'd create packages and things like that. But for the purposes of demonstration, this works fine. So feature extraction, load data, pre-processed and split, and we're at feature extraction at this point. Feature extraction. Okay, so the next step is to train the model. So train model. So this is where we extract features from the text data using the term frequency, inverse document frequency vectorizer, and it's basically transforming text into matrices. So model rather, model equals train underscore model, x underscore train, term frequency, inverse document frequency, and y train. So here, very interesting. So here what we're doing is we're saying this is our matrix, our term frequency, inverse document frequency matrix. So essentially the text that we've converted into a vector, and here is the training data. So here are the correct values that answer this model, right? So that's how you, and this is how we discussed about training originally, is to train in machine learning. One way to train is to provide a set of data and provide the correct answers to that set of data. So is this email a ham or is it a spam? So for each email, we're telling the model if it's ham or spam. So train model, that's that step. The next step after that is to evaluate the model. So evaluation of the model is just a step where we're going to get some statistics on how well the model is performing. So evaluate model. So we have a function called evaluate model that we developed in an earlier part. Model, So model x under x test. So y test. So the test data that we developed, and we discussed the 80-20, dividing training data and testing data, 80% for training and 20% for testing. That 20% is being used to evaluate the model. So the last step in this process is to test live inference. So this is the part where we test the model. So let's create some sample emails here. _1 is equal to urgent business. Actually, I'm just going to copy this and paste this, guys, because it'll go a little bit faster. I have this here. So, sample email 1, urgent business notice, click to receive your cash payout now. We can kind of guess whether that's going to be ham or spam. We should expect the model to define this as spam, right? So urgent business notice, click here to receive your cash payout now is clearly a spam email. If you received an email like this in any context, it would be spam, work or personal email. Hey mom, just checking in to see how you are doing. The spam detector should, in this case, define this as ham because this sounds like a legitimate email. And the final email, free vacation, limited time offer, click here to claim your cash. That to me sounds also like it's a spam email, right? So, and so results, I'm going to do this to make it quick. These are the results. So we're going to predict spam for each one of these emails. And finally, we're going to print a message out for each one of these to tell us what the result was. Okay, so let's run this, and what we should get is we should get a kind of like a spreadsheet showing us how the model is performing in terms of accuracy, F1 score, and things like that. And then we should also get the result in terms of the prediction, how the model is actually performing. So email classifier.python. We end up with the report. So the precision, recall, F1 score, and support. And then we end up with the decision essentially on whether each individual email that we're attempting to predict is ham or spam. So precision is the ratio of correctly predicted positive observations to the total predictive positive observation. Recall is the ratio of correctly predicted positive observations. And F1 score is the harmonic mean of precision and recall. So this table here is, in this particular example, because it's so simple, everything's 100%. But as you get into larger size data sets, you may end up in a scenario where these numbers deviate from 100% a little bit. And that will indicate, model accuracy is never going to be 100% with massive data sets. And we can see here that the results, message, urgent business notice, click here to receive your cash payout. It predicted spam, which is correct. Hey mom, just checking in to see how you are doing. Ham, which means it's good. It's an email, it's a desirable email. And then the free vacation limited time offer, click here to claim yours, is spam. So the model predicted correctly for each one of the test emails. Now, if you want to flesh this out a little bit more and build something that's a little bit more complex, a little bit more something that's a little bit more useful for the real world, you could build on this. You could incorporate a database, and that database would have, maybe it would have 10,000 ham and spam emails within it, and it could even grow. It could be further trained based on new data. So that concludes the classifier series, everyone. I hope you enjoyed it. I hope you learned, and I think it's really interesting. And there's more to come. So appreciate it very much, and have a good rest of your day. Thank you.